sun is the source of most of our energy here on Earth. Energy from the sun is used to produce electricity using photovoltaics and solar thermal plants. That same energy is also used for heating using solar domestic hot water systems, hydronic heating, solar air heating, and solar cooking, just to name a few. This video will talk about how the sun produces that energy. The sun produces energy using a process called fusion. Let's start our explanation of fusion with the atom. You've no doubt heard that everything is made up of tiny things called atoms. We use a very simple physics model to describe them. At the center of an atom are protons and neutrons. We call this center the nucleus of the atom. That's where the word nuclear comes from, since anything to do with nuclear deals with stuff in the nucleus of the atom. And to complete our model, circling around the nucleus are electrons. Different types of atoms have different numbers of these parts. This is one variation of a hydrogen atom, just a single proton and an electron. This is another variation of a hydrogen atom. It has a neutron added to the nucleus. This variation is called deuterium. And just to show you a more complex one, this is a carbon atom. So back to the sun and the process of fusion. For this we'll ignore the electrons since we're dealing with the nucleus of the atom only. The sun also is made up of atoms. Since the sun is so massive, it has extremely strong gravity, much stronger than the gravity here on Earth. This gravity pulls the atoms together. Normally the nuclei of the atoms don't want to get close together. The protons repel each other. But the sun's gravity is strong enough to overcome that, and when two atoms get close enough together, they merge, or fuse, to become a new atom. And that's where the term fusion comes from. So how does this produce energy? Well, take the example of our deuterium atom with its proton and neutron in the nucleus. Again, we're ignoring any electrons. It takes energy to hold neutrons and protons together in a nucleus like this. Let's make up a pretend amount for the quantity of that energy, 3. The actual amount isn't important for understanding the concept. We'll bring back our hydrogen atom. Since it has only a lone proton in its nucleus, there's no energy needed to hold things together. There's only the one thing. So the total amount of energy holding stuff together for these two atoms is 3. When the sun fuses these two atoms together, a new type of atom is produced called helium. As you can see, it has 2 protons and 1 neutron in its nucleus. The energy needed to keep this atom together, though, is only 2. But remember, we started out with an amount of energy 3, and now we're using only 2. So where did the extra energy go? In this case, it's sped away with this expanding wave called a photon. A photon is an electromagnetic wave that has energy and expands outward as a large sphere-shaped wave, carrying away our missing energy of quantity 1. So the total energy is still 3. 2 to hold the new helium atom together, and 1 carried away elsewhere by the photon. But only a small portion of that wave and energy will hit our solar panel on Earth. So we'll illustrate that small portion as this fuzzy wave particle thing. Eventually the energy in that photon is carried up through the interior of the sun until finally it emerges. It then makes its way to Earth and to our solar panel for producing electricity. And now you know the trick that makes fusion produce energy. If you fuse 2 atoms together, then the amount of energy needed to hold the new bigger atom together is less than the total energy that was needed to hold the original atoms together. Well, thanks for watching. I hope you learned something from this video. See my YouTube channel, rimstar.org, for more solar videos like these. You'll find them in the Renewable Energy playlist. And don't forget to subscribe if you like these videos. Bye for now.